Hi children, today we are going to start with differentiation part 2. We have already learned rule number 1 and rule number 2 in our first video. Rule number 3 is if you differentiate a constant, we can understand that that term is without any x terms. Therefore, the answer is 0. Rule number 4. Differentiation of multiple terms. If any differentiation terms are separated by additions or subtractions, we can differentiate them separately and you can use the operation in between them. For example, if you differentiate ax to the power n plus or minus b times of x to the power m, you can differentiate ax to the power n separately and bx to the power m separately and you can use the intermediate operation. Let's try to verify this theory from example number 1. There you can see you have to differentiate 3x to the power 5 plus 4x to the power 3 minus 2x to the power 2. If you use this rule number 4, you can differentiate 3x to the power 5 separately, 4x to the power 3 separately and 2x to the power separately, and you can use the intermediate operations. 3x to the power 5 and 4x to the power 3 is addition, therefore you can put a add in between that. And there is the operation 4x to the power 3 minus 2x to the power 2. It's a subtraction, therefore you can put a minus mark in between 4x to the power 3 and 2x to the power 2. By using previous principles, you can differentiate 3x to the power 5 as 3 times of differentiation of x to the power 5, 4x to the power 3 as 4 times of differentiation of x to the power 3, and minus 2 times of x to the power 2 as minus 2 differentiation of x to the power 2. Then the answer turn up into 3 times of 5 x to the power 5 minus 1 plus 4 into 3 times of x to the power 3 minus 1 minus 2 times of 2 into x to the power 2 minus 1. And our final answer turn up into 15x to the power 4 plus 12x to the power 2 minus 4x. From example number 3, let's try to clarify this problem further. There the problem is differentiation of 10x to the power 9 plus 2x to the power 6 minus 2. There is an important term added over here. Minus 2 is independent from x. Therefore, you can differentiate them separately. Differentiation of 10x to the power 9 plus differentiation of 2x to the power 6 minus differentiation of 2. Now you can write your answer 10 times of differentiation of x to the power 9 plus 2 times of differentiation of x to the power 6 minus 2 times of differentiation of 1. How does this 1 came is, you can write 2 as 2 into 1. Then if you take 2 out, the remaining term would be 1. Now the answer turn up into 10 times of 9 x to the power 9 minus 1 plus 2 times of 6 x to the power 6 minus 1 minus 2 into 0. Because differentiation of 1 is a constant, therefore answer is 0. Then you can write your final answer as 90x to the power 8 plus 12x to the power 5. Now children, use this example to verify with the previous principles. There you have to differentiate 10x to the power 9 plus 2x to the power 6 minus 2x to the power 2. The final answer turn up into 90x to the power 8 plus 12x to the power 5 minus 4x. As I mentioned you before, you cannot apply the same principle if the terms are separated by multiplications or divisions. From the first example, you can see the operation between ax to the power n and bx to the power m is multiplication. Therefore, you cannot write that division as differentiation of ax to the power n into differentiation of bx to the power m. In the second example, the operation is a division. Therefore, you cannot write the differentiation of ax to the power n divided by bx to the power m as differentiation of ax to the power n divided by differentiation of bx to the power m. From this example, the differentiation of 3x to the power 5 into 2x to the power 4 is not equals to differentiation of 3x to the power 5 into differentiation of 2x to the power 4. We will be learning this theory in our upper grades.